You're not going to believe this, but I have created an app to explain the universe. Here we go. Here we are, the quantum simulation. Just pretend that this is the universe and it's made up of matter that's all in infinite superpositions. So it's just an infinite, never ending quantum grid of quantum data, and all of the data is in a superposition of representing everything infinitely all at once equally with no outliers. But if an observation was to be made by an observer who had the desire to find specificity in this infinite data of equality, then we could potentially zoom right in onto a specific particle and actually observe it. And in a basic universe that follows our rules, there's not much to observe in the early stages except quarks or electrons, for example. And so we could make that observation. There's an up quark. We'll make another up quark, and we'll observe a down quark. And quarks combine in different ways to create different structures. And when you have two up quarks and a down quark, then nearby you might observe a proton because they form together and create a proton. And over here, where you may have had a down quark and a down quark and an up quark instead, you might observe a neutron. And if you were in a universe full of infinite possibilities and you were specifically observing a proton and a neutron, and you might want to observe what is the meeting of them, you might observe deuterium, for example. Now, if you were to create some more things like a proton and an electron, and you were to observe what might happen at the meeting of them, you might observe hydrogen, for example. And so this process of observing and revealing the specificity in the infinite, endless equality is exactly the quantum reality of this universe. And through successive observation and successive processing and fusion, this universe begins to get more complex literally rapidly, exponentially. And this is just one little tool I'm working on to help explain all of that.